Yo, Vanguard. Quick question. How do you undo exponents? For example, let's say you had a square shelf that you know the surface area for, but you didn't know the dimensions. You know that the side times the side, or side squared, would give you the surface area. So you need to undo the side squared. Well, we use radicals for that. So what are they? Radicals, or roots, are when you have a number, let's say x, and you ask yourself what number, let's say y, times itself twice or several times will give you that original number x. In other words, radicals undo exponents and give us back the base. In fact, it is a fractional exponent. Remember the cowboy rule? If you need a refresher, check out our video on exponents. In this video, you'll learn the basic anatomy of a radical, the rules of radicals and how to simplify radicals, adding and subtracting radicals, multiplying and dividing radicals, rationalizing radicals, and finally, solving radical equations. Ready? Let's jump into it. First up, we have the anatomy of a radical, which is made up of three main parts. To start, we have the radical itself, then we have the radicand, and finally, the index. Of course, the radical tells us what operation we are about to do. The radicand is the number x that we spoke about earlier. This is the number in question. And the index tells us how many times a number y needs to multiply by itself to get x. For example, let's take the square root of 16. We are asking ourselves, what number times itself twice, because it's a square root, will give us 16? The answer, of course, is 4. With me so far? Okay, let's jump into the basic rule of radicals and how to simplify them. A radical is simplified when it has no square factor and is not a fraction. For example, 33 has no square factors, meaning there is no number times itself that will give us 33. So, if radicals undo exponents, then to simplify radicals, we just need to prime factor the radicand. Let's take the square root of 144. We know that the answer is 12, but let's say we didn't. How would we simplify it? Well, we know that 144 is an even number, so 2 must be a factor. So let's divide 144 by 2, we get 72. Then we know that 72 is just 9 times 8. Next, we can prime factor the 9 with 3 times 3, and we can prime factor the 8 with 2 times 2 times 2. Now we have prime factored all of 144. Next up, we look at the index, which tells us how many factors to group up. Since this is a square and the index is 2, we know we need to look for pairs. Had the index been 3, then we know we need to group up trips, and so on. So we group up and take out the pairs by bringing them out of the radical like this. For 144, all the pairs come out nicely, and we multiply these numbers to get 12, which was our answer. However, let's say the index was 3 instead. What changes is we are now grouping up trips, which means only 1 2 comes out, and we're left with an 18 inside the radical. Okay, go ahead and pause the video and try this one yourself. For this one, we see that 2006 is an even number, so we can prime factor by 2. And we're going to keep doing that because it is such a large number that we have not memorized what times what equals 504, or 252, or 126. Instead, we can divide by 2 until we get down to 63. And we know that to be 9 times 7. So 9 prime factors into 3 times 3, and 7 is already prime. Okay, time to group up the pairs and bring them out. What's left is 2 times 2 times 3 times the square root of 2 times 7, or, once simplified, 12 times the square root of 14. Another basic rule to keep in mind is that when you raise a radical to the power of the index, you cancel out the radical and you're left with the radicand by itself. For example, the cube root of 2 cubed is equal to 2. The square root of 4 squared is equal to 4. Next, let's talk about adding and subtracting radicals. This is like combining like terms. If you have radicals with the same radicand and index, then you can just add or subtract the coefficients. Let's take a look at this one. 2 times the square root of x plus 5 times the square root of x. Because the radicals are the same, you can just add the coefficients and get 7 times the square root of x. You would not be able to add these if the radicals or the indexes were different. Go ahead and pause the video and try these two. To solve the first one, we first recognize that the radicand is the same for both terms. That means we are good to combine like terms. So then we would just add the 7 and the 6. We get 13 times the square root of 11. 11 is prime, so we cannot factor that any further. And for the next one, we would do the same thing. Once we've confirmed that the radicand is the same, we can just subtract 5 by 7. We then get negative 2 times the square root of 2. By the way, a simple way to remember this is that you can treat radicals just like variables when combining like terms. So 5x minus 7x is just negative 2x. Next, we'll go over multiplying radicals. The main rule to remember here is that if two radicals with the same index are being multiplied together, you can put them under the same radical. This comes in handy for things like this example. The square root of 8 times the square root of 14 means we can combine the radicands so that it is the square root of 8 times 14. Then we simplify using the technique above, and we get 4 times the square root of 7. Keep in mind that the law of distribution still applies to radicals too. Alright, pause the video and try this next one yourself. Alright, for this one, because the index is the same for both radicals, we can put them under the same roof. So then this just becomes the cube root of 9 times 6. We then simplify by prime factoring this and taking out a 3. And we are left with a 2 inside the radical. Final answer, 3 times the cube root of 2. Okay, once more, pause the video and try this one. This one's a little different, right? For this one, you first want to use the law of distribution and multiply the negative 3 times the square root of 3 by both the 2 and the square root of 6 inside the parentheses. We then get negative 6 times the square root of 3 plus negative 3 times the square root of 3 times 6. We then simplify and get negative 6 times the square root of 3 minus 3 times the square root of 18. We can group up a pair of 3's in the square root of 18. Therefore, that simplifies to 3 times the square root of 2, which is all that's left inside. Putting it all together, we get negative 6 times the square root of 3 minus 9 times the square root of 2. Because the radicands are different, this is all we can do. Next, let's look into dividing radicals. Just like with multiplying, when dividing radicals, if the indexes are the same, then we can put them under the same radical. Divide what's inside and then simplify. For example, if we have 4 times the square root of 14 over 8 times the square root of 2, we can first separate the coefficients from the radicals, then combine the radicands under one radical. We then get 4 over 8 times the square root of 14 over 2. This simplifies to 1/2 times the square root of 7, or to put more neatly, the square root of 7 over 2. Okay, your turn. Pause the video and try this one. Super easy, right? Let's combine them into one radical, then we have 80 over 10, which is just 8. We then break down 8 into 2 times 2 times 2, group up a pair, take it out, and we are left with 2 times the square root of 2. BT dubs, the square root of 8 is a good one to memorize. Think you got the hang of it? Then pause the video and try this. Okay, this one looks insane, I'm not gonna lie, but it's not too bad as long as you use everything you've learned up until now. First, they share the same index, so let's combine them into one radical. So we have the cube root of 54 times a cubed times b to the 5th power over 16 times a squared times b squared. Now, do you remember from the previous video, the dividing exponent lesson? We can just start canceling things out. 54 over 16 simplifies to 27 over 8. A cubed over a squared just leaves 1a. B to the 5th power over b squared just leaves b cubed in the numerator. Then we can break it down into prime numbers. We have the cube root of 3 times 3 times 3 times a times b times b times b, all over 2 times 2 times 2. Because this is a cube root, we are grouping up in threes. So we can take out a 3, a b, and a 2 from the denominator. We are then left with 3 times b times the cube root of a over 2. Moving right along, we have rationalizing radical expressions. To understand this, we first need to know that in math, we don't like radicals in the denominator of a rational expression. Think of it like improper math grammar. So, anytime we find ourselves with a radical in the denominator, we need to rationalize it. We do this with a simple mathematical principle. We want to change the way the expression looks without changing the value of it. How can we do that? Well, we can multiply the expression by 1. Doing so will change the appearance, but it won't change the value because anything multiplied by 1 is just itself. Then you might ask, well, what would multiplying something by 1 accomplish? The number 1 doesn't need to look like 1. It can be a number over itself. That will have a value of 1, right? Confused yet? Don't worry, check this example out. Here we have root 10 in the denominator. To rationalize it, we simply multiply everything by root 10 over root 10, which has a value of 1. So again, we're not changing the value, we are just changing the appearance. Remember that a radical times itself will just undo the radical. So root 10 times root 10 is just 10. So we are now left with 5 times root 10 over 10. We can simplify the coefficients and we're left with root 10 over 2. Okay, try this example on for size. Go ahead and pause the video. In this one, the main thing that's different is that there's a coefficient of 4 in the denominator. We can ignore that for now. To rationalize, we will multiply the entire expression by the square root of 5 times x times y cubed over itself. We don't need to include the 4 because it's not included in the radical. Okay, multiplying it out, we then get the square root of 15 times x cubed times y to the 6th power over 4 times 5 times x times y cubed. To simplify, you just take the pairs in the numerator and that simplifies to x times y cubed times root 15x over 20 times x times y cubed. The x's and y cubes in both the numerators and denominator cancel each other out, and we're left with root 15x over 20. Great job if you were able to do that one yourself. If not, no worries. Just go back and rewatch my solution a couple of times. Alright, let's move on to the sum difference rule in the denominator. Up until now, we dealt with only multiplication in the denominator. Things get a little more dicey when you have addition or subtraction in the denominator, and we can't just multiply by the radical over itself. We need to use what's called the conjugate. The conjugate is an expression with an opposite sign. So if you have a plus b, the conjugate to that would just be a minus b. or the conjugate of root 2 plus 1 would be root 2 minus 1. So if we wanted to rationalize 8 over root 2 plus 1, we would multiply the conjugate root 2 minus 1 over root 2 minus 1. Then to simplify, we follow the same steps as in rationalizing radicals. We get 8 times the square root of 2 minus 1 over root 2 plus 1 times root 2 minus 1. The numerator simplifies to 8 root 2 minus 8 over root 2 squared minus root 2 plus root 2 minus 1. Root 2 squared is just 2, and the negative and positive root 2's cancel each other out. So we are left with just 1 in the denominator. Final answer, 8 root 2 minus 8. Not too bad, right? Go ahead and try this one yourself. Okay, first we multiply by the conjugate of the denominator, which is 4 minus root 5 over 4 minus root 5. We then get 4 times root 3x minus root 15x over 16 minus 4 root 5 plus 4 root 5 minus the square root of 5 squared. The denominator simplifies to 16 minus 5 and further simplifies to just 11. We can't simplify the numerator, so the final answer is 4 root 3x minus root 15x over 11. You hang in there so far? We have one more concept to go over, radical equations. These are of course equations with radicals in them. We are now putting everything together to solve for the unknown variable. The first step in solving radical equations is to start with the radical itself and try to get rid of it. We can do this by raising it by the same power as the index. For example, square it if it's a square root, cube it if it's a cube root, etc. Remember, you need to do the same thing to one side of the equal sign as to the other. Then, once the radicals are gone, it just becomes a regular algebra problem and you can solve as usual. Let's try this. Here, the first thing we need to do is isolate the radical by adding 2 to both sides. Then, once the radical is alone on one side, we can just cube both sides. Once the radical is gone, we are left with x squared plus 4 is equal to 2 cubed, or 8. We treat the rest like a regular algebra equation, and voila, we get x squared is equal to 4. Here is where it gets a little interesting. To solve this, we need to square root both sides. Now remember from the beginning of this video, a square root states a number that when multiplied by itself gets the radicand. In this case, the radicand is 4, and the number is a x. Therefore, when we solve this, x can be either positive 2 or negative 2. Because in both cases, we get 4 when multiplying by itself. The answer is then x is equal to positive or negative 2. To memorize this rule, here's the rule of thumb. If you square root a variable, the answer should always be positive or negative. Alright, home stretch. Go ahead and try this one out. Alrighty. Step 1 to solve this is to square both sides to get rid of the radical. Then it just becomes a regular algebra problem. Here, however, it looks like it's going to be a quadratic equation, or trinomial. So we will go ahead and move all the terms to one side and keep a 0 on the other. So we get a squared minus 10a plus 16 is equal to 0. We then ask ourselves, what times what gives us 16, but when we add them together gives us negative 10? The answer is then negative 8 and negative 2. So we factor to a minus 8 times a minus 2 is equal to 0. Therefore, a is equal to either positive 8 or positive 2. Alright, how did you do? If you were lost on how to factor this quadratic equation, see our video on factoring trinomials. Alright, my Vanguard, congrats, you've made it through radicals. Feel free to watch this video a couple of times to really memorize the rules and techniques. Otherwise, take care and I'll catch you next time.